Okay, so in your last class we saw about the flow control, which how the data are transferred to one end to another end. So in your this class we are going to see about the media access control, where this media access control also has the name of hardware address, physical address or Ethernet address. If you see these three addresses, you might be heard somewhere, or you might have seen these somewhere. So these three addresses, how they can be defined is, once they can be defined with an hyphen, or they can be defined with a dot, or they can be defined with a double dot, that is your semicolon or something. So for example, this hyphen is 119 hyphen 12 hyphen 20. So this was your first address where it goes on till your 128 bits, where your data is limited to 2 to the power of 24. So with this you can say it as an IP address also, because with this IP address only, the sender, that is me, I am having an IP address, the receiver at the other end is having another IP address, where this two IP addresses connected, and this flow control only directs the signal from which system to which system the message is transferred, or from which end of the part to another end of the part the message is transferred. So only with the help of your IP address. This IP address is having only your address which is containing of 2 to the power of 24. So in previous days we have used the hyphen symbol for your IP addresses. So after your hyphen symbol only, we are using the dot symbol of IP addresses to transfer your data from one end to another. And now what we are using is, we are using the IP address of semicolon, which consists of your alphabets too. So now in colleges we use this dot IP addresses to allocate or to find your systems. But whereas in your semicolon we are using the alphabets such as H1, C1, or semicolon and 1121 IJ. So it contains of your 128 bits of your IP addresses of your semicolon. So these addresses are your media access control. This media access control is nothing but the data which flows from one end to another end, which uses a particular IP addresses which directs your links from one end to another. So this MAC access control plays a very vital role, which is used to direct your signals. So next we are going to see about your random access control. So in this random access control, as we see, the same packets, the same data, the same messages sent from one end to another end. So there is no difference between this random access memory also. So in this we are having two types of random access memories. That is, one is your Aloha memory and CSMA access. So in this Aloha memory, you are having two types. So one is your pure slotted, and your another one is your slotted access memory. So in this pure slotted access memory, what it does? So pure access, what it does? It transfers your data without any error or any error detection correction or any mistakes. So where there are no mistakes, the data pack which is slant go with the flow. So it is known as pure access. So next is your slotted access. So in your slotted access, the messages while transferring or while sliding to your windows from sender to the receiver side, it takes a break from one end to another end. So it happens to have a break in between, is known as a slotted access. So next is your CSMA, that is carrier sense multiple access. So in this carrier sense multiple accesses, it transfers from one end to another end, the messages from one side to another side, the continuous messages or the break messages which is going with the flow, it happens to have a carrier sense multiple access. So in this also you are having two types. that is CSMA, CA and CSMA, CD. So in this CSMA and CA, this is a collision avoidance where the message is sent from one end to another end. It gives the data. And next is your collision detection. It signals the data previously itself. So these are your types which is in your random access memory and media access control. So thank you.